Okie dokie. Today we're going to be working on Unit 1, Day 7. We're going to first start out with a few review problems from just like things that we've done thus far in this unit. Okay, so make sure you understand them. If you want to pause it and actually do them and then come back to the video, see if you are correct, that would probably be the best bet. Okay, company's guidelines call for each gallon of milk produced not to vary from its stated volume of 128 ounces by more than 2 ounces. Write and solve an absolute value inequality to describe the acceptable volumes. All right, so right here, when we talk about the word problems of these, we always did the absolute value x minus what the optimal amount is. So each gallon of milk should have a volume of 128. That's what we want it to be. All right, and then less than or equal to 2 is what it can vary by. So that's what we put on the other side. That's what our margin of error is. That's what our tolerance is. So if they want you to write the inequality, this is what it looks like. Now, if they want you to solve the inequality, now we can set up two inequalities and solve them by hand like this. All right, keep one as is. And then the other one, what we would do is we would flip the sign and change that to negative. So when I go and actually solve this, all right, I get x is less than or equal to 130. And here I get, when I add 128, I get x is greater than or equal to, let's see, 126. All right. Here, if you think about a number line, what actually happens is, all right, we got 126. This is greater than or equal to 126, so it's going this way. And then 130 is here, and this says less than or equal to 130, so it's here. So it's actually an and statement. So we're not going to leave our answer like this, and we talked about this. You want to actually write it as an and statement. Put the lesser number on this side, put the greater number on that side. We can also solve these, instead of solving it by hand, we can solve it using Desmos. So here we go. We've got Desmos right here. If I go and actually say absolute value, don't forget absolute value is when I hit the keyboard and it's right here. All right. And then I hit X minus 128. All right. Arrow over. I'm going to say less than or equal to 2. All right. Now, when I go to find this right over here, all right. Notice those 128 is kind of a big number, and you can see it, and you can zoom in and you can see that number. Notice, think about our number line that we had right here. Doesn't this kind of look like that number line? And it's in between 126 and 130. When it's a solid line, we use equal to. When it's a dotted line, we take off that little bar equal to sign off. Okay, so let's go solve the following inequality. Now, if you are solving this by hand, you're going to have to add 5 first. All right. So when I do that, I get -6, and then I divide by 2. So absolute value is like this, greater than or equal to -3. All right. And you can create two equations when you're actually solving this. X minus 3 is greater than -3, and then x minus 3 is less than -3. All right. And you can go ahead and start solving it. So there's our two equations. Sorry, y'all didn't see it. All right, like that. And you can solve it. But something special actually happens with this. So I'm going to put the original problem in here. 2 absolute value x minus 3 and then -5. And then we're going to say greater than -11. All right, we'll start zooming. And you're like, wait a minute, I don't see where it's like just colored in between two lines. I don't see where it's colored in this side and that side, and there's a gap in the middle. Do you see how everything's colored? So do you remember what it is? It's all real numbers. So we can say all real numbers. Okay, we can also say like negative infinity to infinity, because everything is going to work. Every x value is going to work for this right here. Okay, so that's solving inequalities, absolute value inequalities. But let's look, we've got a piecewise function. Sometimes they give us the graph just like this. So we're going to find each of these values. F of -3. Remember, these refer to the x values. So -3, okay, I go where it hits the line, and it's hitting at negative, let's see, 1, 2, 3, -3. All right. F of 2, I go to x equals 2. However, I got an open circle and I got a closed circle. What do we want to look for? We want to look for the closed circle, which is up here, 1, 2, 3, 4, 5. All right, f of -1, again, you want the closed circle, so that value is going to be 2. and then f of 4. Go to 4, and that value is at -1. All right, so make sure you can do that. Given a graph, or remember piecewise functions, you also have to know how to put them in the graph. All right, so let's start out with our lesson today. And what we're doing is, so grab your workbooks right quick, and I want you to go to page 94. All right, now I didn't have a title on my sheet, so I'm going to actually write this. All right, this is U1, day 7. We're going to be talking about inverse functions. All right, we're going to be talking about inverse functions. So let's look at this right here. Lynn stated if I have 60 minutes to ride, I can go 12 miles. All right. So that means in 60 minutes, I can go 12 miles. Well, let's see if we can fill this out. All right. Well, think about it. Half that time, you can go half of that. So half of 60 is 30. So I can go 6 miles. All right. Well, let's see if we can do a couple other things. Okay. Notice this is breaking up into thirds. Well, think about if I divide 6 into 3, that's going to give me 2. All right. So therefore, what if I go 2 miles, then I go 4 miles, then I go 6? Look at the pattern here. It's just increasing by 2. So 8, 10, and then 12. All right. Now let's look at this. May stated, I plan for every 5 miles to take me 25 minutes. All right, so every 5 miles, all right, the problem is 5 miles is right here is 25 minutes. Okay, so let's think on this for a second. All right, so if it takes me, so let's think about this for a second. 25 minutes. All right, if I divide by 5, all right, miles. All right, that gives me 5. So it's 5 minutes for 1 mile. All right, so 5 minutes for 1 mile. So if I go 2 miles, how many minutes is it going to take us? It's going to take us 10. All right, so if I go 4 miles and it's 5 minutes for each mile, that's going to give me 20 because I'm doing 4 times 5. All right, so 6 times 5, that's going to be 30. And you can notice every 2, I go up 10 here. So that's going to be 40. That's going to be 50. And then that's going to be 60. All right. Now these, if you go look at the graphs or the tables for a second, what do you notice? Do you notice how these are inverted? Okay, like here, these are our X values, but they're the Y values down here. Here's our Y values. Here's our X values. Okay, so notice we've switched our X and Ys. All right, so let's go answer some of these questions. In Lynn's model, what distance corresponds with 30 minutes? Okay, so 30 minutes, it's 6. Okay, so 6 miles. What do these two numbers mean about Lynn's biking? So basically, every 30 minutes, she goes, or he, 6 miles. All right. Okay, so let's go a little bit further. In May's table of values, what time corresponds with 6 miles? All right, so right here, 6 miles is 30 minutes. So that's going to be 30. All right, so when May goes 6 miles, it takes her 30 minutes. All right, but either way, they've both gone 6 miles in 30 minutes, correct? All right, that's correct. All right, so how will Lynn and May each compute their rate based on how they described their bike rides? Who is the fastest? All right, so Lynn's, all right, for basically the distance, that's the Y value. Lynn is doing, if we go back up to here, let's think about it. All right, here, basically, how do we get 2? 10 what gives us 2? 20 what gives us 4? Well, if you've noticed, each time, like if I divide that by 5, it gives me 2. If I divide that 20 by 5, it gives me 4. 30 divided by 5 is 6. So every time I take the time and I divide it by 5, it gives me. All right, Lynn's distance. Well, let's talk about May here. Okay, so let's look at it. Let's see if we can make any connections. Well, this time, every time we multiply this by 5, it gives us that number. All right. So every time, all right, and notice that's distance. Every time you're taking the distance and multiplying that by 5, it comes out to be the time. All right. So who is the fastest? Well, if you actually look at it, isn't it the same? So here, they are equal. All right, even though the equations are a little bit different and the tables are a little bit different. So let's talk about, well, what did we just do here? All right, so number 2, we're on page 95. We're going to use the tables you made for Lynn and May's biking to write an equation for each ride. Okay, so here we actually already did make the equations. All right, so here this is t divided by 5. And then this was 5 divided by d. All right. Notice this was d of t because t is the basically x value, our independent variable. Here, this was t of d because d, our distance, was our independent variable here. So we already wrote our equations. All right. Now, here we go. Let's look at this one right here. Here's the graph of our equations that we wrote, but this time, instead of having t and d in here, they have x and y. So y equals 1/5 x, and please realize this one up here, not only is this t divided by 5, you can write it as 1/5 t, okay? And that's what they have done here. And then we got 5x, okay? Highlight or trace the graph of 1/5 x in one color. Okay, so let's do this. Let me draw some colors. Okay, so highlight or trace the graph of 1/5 x in one color. Okay, and then the next trace graph, all right, that in another color. Okay, and label the axis in the matching color. Okay, so here, what it's talking about is, so for this one was lens right here. Well, lens, if I go back to the table, my X value was time. So I'm going to highlight that. And then my Y value was distance. All right. And then here for the orange one, that is May's. Well, the X's were my distance. And then the Y was time. So I'm going to highlight them in the color that they're in right there. Okay. All right. Now, let's do number 3. On the graph, mark one point on each graph where both riders have biked for the same amount of time. Okay, so let's just mark one. So here, what if I say, let's do an easy one. So here, this one means time, so that's 50 minutes. All right, so that's the point 50, 10. So in 50 minutes, he's gone 10 miles. All right, so look here, time, let's go to 50. All right, this time the point's 10:50. All right, so we just marked it. All right, and I want you to notice these points. Do you see what they've done? They've switched X and Y. All right, so pay attention to what we've done here. All right, so let's move on. And let's talk about number 1. We're for activity 3. We are on page 96. I just flipped over a page. I've got some sticky notes here. This is for myself, but these are some things that we're going to be doing. All right. Now keep in mind, I kept saying something about switch your X and Y's. All right. Well, what we're doing is when we switch our X and Y's, we are creating an inverse. So make a note of here. This is when we switch our X and Y values. All right, and that's what May and Lynn did. They switched their X and Y values, and then they were the same. Okay, use the two representations of f of x to find an equation for. Now, we haven't seen this before, but what this means is inverse. And anytime you see this, it looks like f to the negative 1 of x. You'll hear me say that. We want to find the inverse. Okay, so use the representation of f of x to find an equation for the inverse. Now, since they're giving us a table, I'm going to do it in 2 ways. I'm going to find the table for the inverse. And when we do that, just think when you hear inverse or see this sign, you switch your x and y's. So this is -6, -1, -5, 0, -4, 1, -3, 2, -2, 3. But not only can we write the table as an inverse, you can write the equation. Now watch how I do this when I find the inverse. Okay, so here, this table actually matches this function right here. All right, so let's write the equation. Now, whenever we write an equation, the first thing is we want to switch x and y. So here we go. Now, please realize that f of x means y right there. So now I'm going to switch it. X is going to go here. Y is going to go here. Now, our next step is to solve for y. All right, so let's go solve for y. All right, well here, this one's going to be a one-step thing. We're going to solve for y here. Add 5 over, and we get x plus 5 equals y. Now, instead of writing y, I'm going to write it as inverse of x using that notation. And guess what? If I actually use this equation right here, like I plug -6 in for x, -6 plus 5, what does it come out to be? -1. We created the table for the inverse before we actually wrote the inverse equation. All right. So let's go look at this too. And here's another thing. I'm going to go to Desmos right quick. And in Desmos, what I want you to do is let's go plug in y equals x minus 5. All right. And then I want you to plug in y equals x plus 5. So we have our function that we had originally, and then we had our inverse. Now, one thing about inverses and one thing you need to know, all right, and I can go back and use those Lynn and Mays and show you this as well. These are a reflection. It is a reflection over the line y equals x. All right, so here we go. If I plug in y equals x, all right, notice it flips. Reflection means flips. It flips over that green line. All right, now I'm going to plug in, if you want to flip over back to that page. Okay, Lynn and May. So we had 1/5 x was one equation. You don't have to put it y equals if you don't want to. And then we have 5x. All right, now let's put in the line y equals x. Does that look like they flipped over that line? All right, that's actually how you know that you have the inverse. Okay, if you graph both equations and it reflects over that line y equals x, you know you have an inverse. All right, so let's move on to number 2 of activity 3. Okay, so right here, and again, I have another sticky note. It's just tell me what I need to do. All right, so here we go. Now, one thing we can do, it says use the representations of f of x to find an equation for the inverse. Now, one thing we can do, we know it reflects over that line y equals x. This is that line as a dotted line, y equals x. This is the one that says 1/2 x minus 3 that they have written over here. But what we can do is we can go to certain points. Like I can see this point right here. That's the point +1, sorry, -1. Well, if I flip that around, -1, all right, -1, 1. So -1, 1 is here. All right, -1, 1. All right, let's go find another point. Like I like to find the nice ones. This one's at 5, 1. Okay, so now I need to do 1, 5. You just flip-flop your x and y's. All right, another nice one right here. That is the point 11, 4. So go to 4, 1, 2, 3, 4, 11, and it's up here. And I got 3 points, so I'm going to go ahead and connect them. All right, so let's make some observations here. Does it look like it reflected over that line y equals x? Yes. All right, so to find the inverse, you just have to switch your x and y's. All right, now we could write an equation from here. However, it's going to be a little bit difficult. So let's use those steps that we just did to write an equation for this. All right, what was your first step that we talked about? All right. Switch your X and Y's. Now this is Y right here. Okay. I just wrote over top of it. I've got to switch them. X equals 1/2 and then Y minus 3. I kept my parentheses. All right. Now what we want to do is solve for Y. Well, some of you are going to want to distribute, which is perfectly fine. Okay. All right. And then we add 3/2 over. Okay. I like to keep, now you can put 1.5, but I like to keep fractions at first. All right. For this next step, because right here, what do you think we need to do to get Y by itself? Now, do you see that it's multiplied by 1/2? So we would multiply by the reciprocal. Some of you may have Y over 2. All right. So you're like, it's divided by 2. So we need to multiply by 2. The reciprocal of 1/2 is 2. But to get rid of a denominator, you multiply by that denominator on top. Now notice I put parentheses around this because it gets distributed. 2 times X is 2X. Now when I multiply it here, this 2 cancels that 2 and leaves me with 3. Now these twos cancel and just leave me with Y. So guess what? The inverse, I'm going to switch the Y to the inverse notation, is 2X plus 3. All right. And if you actually go here and you're like, okay, maybe 3, does it look like that's the Y-intercept? It actually does. All right. And is it a slope of 2? Rise 2 over 1, rise 2 over 1, rise 2 over 1, rise 2 over 1. It is. All right. And if you remember anything about linear functions from Math 1. All right. But we can also throw both of these into Desmos, and you'll see that it's a reflection over the line Y equals X. All right. So let's go right here. Again, if you want to, I'm not going to worry. You can skip this. We may have it in class, but as far as, I just want to reiterate this, writing the equation of a line. So here, switch your X and Y. So this is going to be X equals 3, Y minus 1 plus 2. All right, here, some of you are going to distribute 3Y minus 3 plus 2, but then these two get added together. Okay, simplify everything on that one side first. All right, now you're just solving for Y. Add 1. So X plus 1 equals 3Y, and then divide by 3. All right, now on this type of problem, I do want you to realize it can be written in different ways. We can have the inverse written as X plus 1 over 3. Now, if they have this written as a multiple choice item in a question, you may not see that answer. Realize both of these are divided by 3. So X divided by 3 plus 1/3. You may also see it as like 1/3 X plus 1/3 like that. Okay, so these are all valid options to have, like if there was a multiple choice question that said, what equation is the inverse of this right here? All right. Okay, so let's move on and let's look at a couple more things. And we're going to focus on, so I'm on page 99. All right. And I'm just going to focus on just a few of these. And we're going to focus on also checking them in Desmos to see if we have the correct thing. All right. So here we go. Let's look at this right here. Now, let's go find the equation. All right. Again, that's Y. So X equals Y plus 1 over 7. Now, we haven't come across this right here. How do we solve this? Well, think about opposite. This is divided. Everything's divided by 7. All right. So what's the opposite of division? Multiplication. So 7x equals Y plus 1. Now, how do I get that 1 away from the Y? Well, notice it's plus 1. The opposite would be minus 1. So 7x minus 1 equals Y, or the inverse. Okay, so how do we know if we did this correctly? All right, you can check for yourself in Desmos, and that's what I'm going to do right now. Now, I'm going to leave Y equals X there because it must be a reflection over that. Now, please pay attention to this. When I just started typing, does that look like exactly what it had up there? No. You have to put that numerator in parentheses, or after you type it, highlight it and then divide it by 7. Okay. All right. Our other one, the one that we got right here, is 7x minus 1. Now, do these look like a reflection over that line? Yeah, it does. All right. Also, if we start to do this, and I'm going to try this. If you say plus and you say table, oops, nope, that didn't work. Hold on one second. I think there's a way. Cogwheel. There you go. If you hit the cogwheel and you hit this, look at the table. All right. And I don't know if this is going to work or not. All right. Here, same thing. Cogwheel, hit the table. All right. Now, if you start to notice, oh, wait a minute. They should resume. Oh, and here's why. Here, if I put in, now notice our tables, what I want to show here is if I put different values, okay? And now let's think about this. If you put the Y value of -15, does it come out to be -2? Or right here, I can see this table. If I put the Y value -8, does it come out to be that X value that they've got here, -1? And it does. Sometimes at first, it actually doesn't look like that. However, you can see this point right here, -1, 0. You can see 0, -1 right here. Here's another thing as well. As you zoom in here and you see, if our black and purple lines do not intersect on that line y equals x, you actually did it incorrectly. All right, all three of these lines should intersect at the same place if they're going to intersect. Sometimes they don't intersect, which is completely fine. All right, so let's go back. I'm going to delete this because I'll check the other ones in a second. All right, let's go to C right here. All right, so here we go. We're going to write the equation. Pause the video at any time and see if you can do it yourself. Here's y. I'm going to make this x equals 3/5 y plus 2. Solve for y. So I'm going to subtract 2. I don't want to divide by or multiply by 5 because the 2 is also not divided by 5. So I want to subtract the 2 first. X minus 2 equals 3/5 y. Now I can multiply by 5, but remember, if you multiply by 5, do it on both sides. 5x minus 10 equals 3y, because these 5's cancel. And now divide by 3. And I'm just going to keep my answer like this. Now, you can write it as 5/3 x minus 10/3 if you would like. Okay, and that is, instead of y, I'm just going to put inverse. Okay, and again, always check your answer in Desmos. It's a quick check. Put y equals x because that's what it should be a reflection over. All right, this is 3/5 x plus 2 was our original. And my answer, I'm going to do this. I'm just going to put this one in parentheses, 5x minus 10, and then all of that divided by 3. I know I did it correct. Now, how do I know I didn't do it correct? Let's just say I had this answer right here. All right, and then I say like plus 10. All right, do you see that these are not a reflection over that line, y equals x, as well as, look, do all three of them intersect in one spot? No, they shouldn't intersect at other spots. If they're going to intersect, they're all going to intersect together on the line y equals x. So you would know you did it incorrectly if you don't see them. All right, let's go do D right here. Okay, so D is going to be very similar to B. This is going to be x equals y minus 1 over 2 because all of it's divided by 2. Multiply the whole thing by 2. So these cancel and leave us with y minus 1. Our last thing is add 1. So this is the inverse. Again, double check. All right, so x minus 1 was our original problem divided by 2, and then we got 2x plus 1. All right, notice that, all right, they all intersect on this line. This does appear to be a reflection over that. All right. Now, let's go to our paper. This does come from unit or page 100. Are you ready for more? However, like they have this on page 100. They just don't have all these. I want to find all this. So I want to kind of put these together. Well, this is a what type of function? Piecewise function. So do me a favor, go into Desmos, and I want you to graph it. We've graphed piecewise functions, so you should know how to do this. If you have missed a day or you don't know how, please follow along. You need to go back and watch those videos as well. All right, so there's the first part. Just make sure you put these in squiggly brackets. All right, and then 2x minus 4, okay, plus 7, okay, and then in squiggly brackets, say, basically, if you hit the shift key and the key beside P, it'll pop up. All right, 4 is less than or equal to x is less than 10. All right, you may want to see this entire thing, and I can see the whole entire thing. All right, so here we go. Now, I want you to notice that on some of these, like, and I'm not going to necessarily start with number 1, we're used to finding f of 4. 4 meant that we had x. So here's x equals 4 if you look at Desmos. All right. And you just now realize I can't get to the end of the red graph. All right. This is where they meet, but I can get to the end here. So what is our answer? It's 7. All right. So here that refers to the x value right there. So again, like right here, number 4, that's going to refer to the x value, what we're used to. Go to 8. 8's going to be up here. And I just hit it. And I just kind of see if there we go. I saw it for a second. There you go. 15. Okay. You can also say x equals, whoops, not 15. X equals 8. And I'll see that it's crossing at 15. All right. But remember this inverse. What should you think of? Switch x and y. So instead of that being the x value, that's the y value. All right. Now, sometimes it is a little trickier. Okay. But why don't we do this? Why don't we say y equals 3? All right. Does it ever cross at y equals 3? And it does. Now, anytime it's a y-intercept, be careful. Make sure it's actually on that. And it does. It equals it when the x is 0. All right, so let's do that again right here. The inverse at 9. So inverse does not mean the x value. This means the y value. So I like to say y equals 9 and actually type that. And where is it hitting? When y equals 9, it equals 5. All right, now right here, same thing. Okay, this is the y value. So when y equals 19, let's plug it in there. All right, just make sure these are intersecting. Okay, right there. But here, we actually have to be very careful. All right, I know it came up with a point, but let's make sure the y actually, especially right here at the end, can I get that at the end? No, I can't. Now, I do see it says 19. Here's my issue right here. Do you see this right here? All right, that is not equal to 10. So, but this is kind of misleading because it says it equals 10. Well, here, there is no solution. Okay, because actually right here, it's an open circle if I take this. All right, let me take that off because I cannot get to the end of that blue line right there. Okay, I can't get to the end. So therefore, if I can't get to the end, it's never going to equal 19. All right, so therefore we have no solution for this. All right, and I have one more question for us. All right, are the following inverses of one another? Basically everything we've done today, how can you tell? All right, there are 2 methods. All right, you can graph it, 3x plus 5, all right, and 3x minus 5. What must they reflect over? The line y equals x. Well, here's y equals x right here. Do these reflect over it? No. If they're going to intersect, all 3 of them are going to intersect in the same place. So no, not inverses. And make a note, does not reflect over the line y equals x. All right, now another way is to actually just find the inverse. So here, if I just take this first one right here, switch my x and y's, all right, and solve for y. So I'm going to subtract 5, x minus 5 equals 3y, and then divide by 3. All right, now your answer can look like this, or if when I divide each of them by 3, it may look like this. Now, does that match the second equation? No. So if you go solve and you actually find the inverses should match up. Or if you want a graph, it must look like it reflects over the line y equals x. And so therefore, since these don't match or it doesn't look like a reflection over the line y equals x, all right, they are not inverses of one another. So today we introduced inverses, and the big key is you switch your x and y's. If you're given a table, switch an x or y's. If you're given an equation, switch your x and y and solve for y. The way we check it is to graph those 2 equations and make sure they are a reflection over the line y equals x. If they're not, then they're not inverses of one another. Tomorrow, we're going to continue looking at inverses as well. So make sure you watch those videos. Make sure you're in class daily so you can understand it.